Hello, Assalamu alaikum. How are you? Uh, in today's lecture, what we will discuss certain things, and one thing that is the very important topic, and it is the revision of the like statistics topic. Uh, I think quite a few times we have already done that, but it is a good revision of that. And what we are going to do, uh, we are having a review. We have a data in question number three. In question number three, that was easy of that book. If where you analyze this, and what we have, we have the temperature of a city, that is Sydney. Now you can see what is the temperature that was given on different days. You can see like uh, 21, then 23, 22 with the half, and that is given in the shape of the dotted form on the graphical format like that. If we have 21 over there, one dot is showing that value has repeated once. Then 22 is showing that has repeated once. But on the 23, that has shown three dots. It means its frequency is 23. So this is how we have plotted that data. And with the help of that plotted data, which I have discussed to you, so that is number of times we have noted it out, like 23, then 24, and you can also see that how many times the other data has repeated. For example, 24 was once, then 25 two times, then 26 was how much time? That repeated by six times. Means that was the temperature which repeated again and again, most frequently. And it is also called the mod of that data. It is also called mod of that data. Then we have other things we have 27, and this is what that is Sydney's temperature in the month of February. Then we have 27, that was repeated twice. Then we have 29, 28, that are also repeated. How much time? 9 times. Okay. Then we have 29 and 30. For example, this was the data that was given to us. If we plotted it on a frequency distribution, on a normal distribution, that is also known as. Here I have temperature over along the x-axis and the number of time. It is also called the frequency that will be plotted on y-axis. If we plot that, you can see like this was 20 and this was 22, this was 24. So every each big block was getting the 2 degree centigrade. 2 degree centigrade difference was that. So if we plotted that, if we know that that is shown out there 24, 25, like 26, 27, like that. So it means each big block, you can see if the 24 is there, it means the one big block, the next block, it means that is 26, it is 28, next is 30, similarly 32, then 34, and these values are repeated there. So if you plot that, it looked like that. 21 was there one time, then 23 was two times. Yes, its frequency now it is 1 and it is 2. Then 24 that has repeated once, that is 1, that it is 2. 25, it means 25 will come between 24 and 26. How? If the one big block is showing the two values, it means that between that, and you know along the graph that if one big value was showing the 10 small squares over there, like I'm now giving you the more precise view of that. Like if that is 24 and this is 26, it means how many small blocks will be there, how many small squares on the graph, 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is 10. It means exactly at the fifth small square, 25 will come. So now we have now plotted it 25, but this is again the presumed thing because the graph will be definitely small, so I'm giving a big display of that. along the board, but it is a little bit big view. But on the graph, you will get the exactly and precise view of that. So 25 two times, then 26. Now plotted it two times, then 27. That is the most frequent value. You can see this jumped up because now along the y-axis one big block was showing 2, so that is 4 and this is 6. Now this and this 6 times, then 27 was 9 times. Yes, 27. So this is 26 and between them now if that is 26, now it is 27, which is 26, sorry, so 26 comes there and 27, even it is bigger than that. That is 9 times because its big block is next big block is 8 and this is 10. Between them, that is having the value of that. This. Then we have 29. Again this 29, 29 for 1 and 30 for 1. So you can see now if you look at that, the graph, now I'm plotting it. I have plotted it, and after plotted it, you can see the values over here, the degree of scatteredness. So if I come to know what's the average for that, so by calculation I have calculated it, and that is definitely how much that we are getting. For example, we are getting the 26 like that. So you can see that most of the values lies left of it. So it is negatively skewed. What it is? Negatively skewed for the temperature of this city, Sydney. This is how I want to revise that how we will decide about a negative skewness and positive skewness. So this is negatively skewed. Why? Because you know that many of the values lie left of it, like average values are less than the average. Most of the values are less than the average value. So it means that is negatively skewed. So this is how actually we plot it. But if I neatly describe it, what it looks like. Now that is called a normal distribution. Now you can see in the normal distribution, this is the average. This is the average score. And if you have, like in this graph, so it looked like that. You can see that most of the values like there, and there. So most of the values are left of the average. So it is negatively skewed. While if you will plot the next the data of Perth, if you will plot it on a neat graph, definitely on the x-axis you will have the temperature, on the y-axis you have the frequency. So it looks opposite to that. How? So the remaining calculation you will do it. You already know about that, how you will get the average summation x over n, how you will get the q1, you know about that. On the box plot you can also calculate, and you can also get by n by 4th value. So these all the value which you have already solved. But main thing I want to tell you that when I will plot the next one, what will happen? It will happen like that. So in the next city, that is Perth, for example, so this is the average and most of the values are lying right of it. So what it tells us, it means most of the values right of it. It is called positively skewed distribution. Positively skewed distribution. This is actually what is the analysis of this data, that most of the values lies right of the average, right of the arithmetic mean or average. It means this is the difference between positively and negatively skewed distribution.